Hey guys, welcome to section 9.1. We're in the last unit, and technically, I think I've talked about this, but just not a whole lot, and I feel like we need to go over it again. So, section 9.1 is graphing simple rational functions. And here is your parent function, your parent rational function. Y equals 1 over x. It's got this orange vertical asymptote and this green horizontal asymptote. They are at y equals 0 and x equals 0. And with asymptotes, you never touch them. So towards infinity and negative infinity, you never touch them. Now, when we get to math 3, there's going to be a few times where we can touch them or cross them locally. But typically, you never, ever, ever touch them. So for our purposes for math 2, you never, ever cross them or touch them. And they are normally drawn with dotted lines, as you see here. But you'll see in the future slides of this lesson that I have just solid lines because I use Desmos. And these two dark lines are the actual function. The asymptotes aren't really part of the function. It's just part of the graph that you need to know so that you don't cross it. So these little dark lines we call branches. And so this particular rational function and all the ones that we will see in Math 2 have two branches. And this just goes into more details at what happens and why this is a horizontal asymptote. So as your x values get larger and larger, so follow my cursor here, as they get larger and larger, what is happening to them? So as they get larger and larger and larger, the y values are getting closer to 0. Okay, that's what I've typed right here. And over here, as your x values get smaller and smaller and smaller, your y values get closer and closer to 0, and that's where the horizontal asymptote comes from, y equals 0. We don't actually touch it though. All right, here, as x values go towards 0, so watch my cursor. As x values go towards 0, from the right side, your y values are getting larger and larger. As your x values go towards 0 from the left side, your y values get smaller and smaller and smaller. And that's just another thing, and that is talking about the vertical asymptote. You're not actually touching x equals 0. All right, x values never touch 0, okay? And so there's a vertical asymptote at x equals 0. And I could keep going and going and going, but I think that's enough there. All right, now we're going to get into, if you haven't already, I'm sure you have, but finish up note card 290. That's just the parent function. Yes, I want the graph on there. I want your asymptotes drawn in, and I want these equations written as well. All right, so now note card 291, we're going to take that parent function, y equals 1 over x, and we're going to do the diagnostics for it. Yes, they're back, okay? And again, I think we've already done this. I just needed another day or two on this. So here's the parent function. The horizontal asymptote is right here. It's y equals 0. It's a horizontal line, y equals 0. Vertical asymptote is x equals 0. Vertical line, x equals 0. Your domain. These branches touch everything except for x equals 0. Remember, the domain is the set of all x values that are accompanied by this graph. And x equals 0, this graph never gets to. So remember the smushing, I could take this blue branch, smush it up, and cover all of that, and this blue branch, smush it down and cover all of that, but 0 would not be covered. So your domain is everything but 0. So remember, you go left to right, negative infinity to 0, union 0 to infinity. Now your range, you smush to this orange, you smush to the y-axis. So again, everything's covered except y equals 0. So your range looks similar. It's just the domain's talking about the x values and the range is talking about the y values. This thing is never increasing. If you follow from left to right, remember it's from left to right. Everything but range is from left to right. So if you follow from left to right, that's decreasing, and it pops up here. That's decreasing. So it's never increasing, but it's decreasing right here on its entire domain. Now remember, 0 is not in the domain, so that's why we have to have two parentheses sets here. So it's decreasing from negative infinity to 0, and then union 0 to infinity. You can't just say negative infinity to infinity, because that would imply that we are defined at 0, and we are not. And why not? Because 0 can't be put into the denominator, guys. Look. Okay, where's this thing positive? Where's it above the x-axis? That's from here to here, so you go left to right. That is 0 to infinity. There we go. Where is it negative? Left to right, so negative infinity to 0. So you're going to have to reach back into the recesses of your mind because it's been a long time since we've done diagnostics. Now our right in behavior, as our x values get larger, that means as x goes to infinity, see the little arrow, as x goes to infinity, what is happening to your y values? Well, your y's are going towards the horizontal asymptote of 0. And over here, as your x values get smaller, so as your x values go to negative infinity, your y's are going to 0. All right, so pause me and finish up your note card 291. All right, note card 292, that was just the parent function. Now, we've got to be able to transform these things, and your transformation rules are very similar to what you've seen before. It's just this function, they're the same actually, just this function looks wonky, and so students get confused. Whatever a is, normally it's 1, but if it's 4, that means it's a vertical stretch. If it's 0.2, that means it's a vertical compression. You're really not going to see anything that's a compression in Math 2. And then, of course, if it's negative, you have a reflection across the x-axis. So instead of your branches being in the first and third quadrant, they'll be in the second and fourth. And we do have an example of that later. The plus k, that I put the in other words there because I knew you guys might want that. If it's a plus k, you move up k units. And if it's a minus k, you move down k units. Over here, the h, if you have a plus h right here, so x plus h embedded in there, it's going to be left k units. And if you have x minus h, it's going to be right k units. So pause me and finish up note card 292. All right, in note card 293, I want to state the transformations. Okay, so if you look at this one, there's my parent function. We don't have a different number on the top. That's just a 1. But we have a plus 3 on the outside. That's the k. And so it's a plus 3, so we move up 3. So that's up 3 units. Now, where do we have this x plus 3? It is embedded in the operation right there. It's like this. So if I have a plus 3, I move left 3 units. Looking right here. You also can just remember your transformation rules. If it's embedded in the operation, you do opposite what you think, left or right. So this one's going to go left 3. Now this one has 2 things going on. It's going to be going down 3 from this, and then right 2 from this, because it's a minus, so it's going to go right. This one has 2 things going on. It's going to be up 2, and then what's that going to be? It's going to be left 1. And this one has a negative 2 at the top. So it's a reflection across the x-axis, and that 2 itself is bigger than 1, so it's a vertical stretch by a factor of 2. So pause me and write all that down. Hopefully that's review, and hopefully you remember your transformation rules. Now we're going to get into note card 294, where we're taking something that's been transformed and we are diagnosing it. All right, so this one's up 3. That means that our horizontal asymptote from our parent, guys, our parent horizontal asymptote is y equals 0. So if it's a plus 3, that means it moves up 3. So my new horizontal asymptote is going to be at y equals 0. And these bullet points are my thinking process and what I did. So I knew I had a new horizontal asymptote. I used Desmos, and I typed in the new equation of that horizontal asymptote. I didn't move left or right any, so my vertical asymptote stayed the same at x equals 0. And then I also, after I typed in a Desmos, I clicked the x-intercept because I'm going to need that for the positive and negative diagnostics. And there you go. That's the screenshot of what I got in Desmos. And the red line is that horizontal asymptote at y equals 3. The green line is the vertical asymptote at x equals 0. And the blue line is the actual rational function. And you'll see that the blue line doesn't cross either the red or the green line. Okay? So when I fill in my diagnostics, I got my horizontal asymptote at y equals 3, my vertical asymptote at x equals 0. Okay, domain. If I take this blue branch and smush it to the x-axis, this part would all be covered, and this little sliver, I would push it up, smush it up, and all of that would be covered up to 0. Same thing here, so my domain looks like this. Now my range I've got to fix. I just copied and pasted this. So my range, if I smush this blue to this green line, okay, the green line is the y-axis, by the way. It's x equals 0. It would be negative infinity up to 3, and it would jump from 3 to infinity. So this one smushes all the way up to 3, and then this one smushes 3 and above. But 3 is not included because that's a horizontal asymptote. Where's this thing increasing? It never is. Y'all, the only time we're going to have increasing intervals is if it's a reflection across the x-axis. And we will have one of those examples shortly. All right, decreasing. This thing is decreasing on its entire domain, so I just copy the domain down here. But yeah, so negative infinity to 0 and then 0 to infinity. Where is this thing positive? Okay, it's above the x-axis. Watch where I'm going, left to right. Negative infinity up to negative 0.333. And that's negative, you guys, so I have to jump up here. So from 0 to infinity, that's where it's positive. Y'all, it's only negative in this little sliver. So left to right be negative 0.333 up to that vertical asymptote, which is 0. So negative 0.333, comma 0. Right in behavior, as x gets larger, what's happening to my y values? They're getting closer and closer to 3. This is always going to be, right here, your horizontal asymptote. Same thing on my left in behavior. As x goes to negative infinity, my y values go to 3. Pause me, rewind me, watch this again, whatever you need to do to understand this, but finish up your note card 294. All right, note card 295, we have one that's been moved left 3, and so my new vertical asymptote is x equals negative 3, okay? But my horizontal asymptote is just y equals 0 because it didn't get moved up or down any. So using Desmos, I typed in the function, my asymptotes, and here they are. The red line is the horizontal asymptote at y equals 0. The black line is the vertical asymptote at x equals negative 3. And the purple line is the actual rational function. All right, so I put in my asymptotes here, my domain. All right, if I take the purple and I smush it up to the x-axis, and guys, here the red line is the x-axis because that's the y equals 0. Be negative infinity up to, what is this x value? Well, it's negative 3. So negative infinity up to negative 3, because that would smush there, and then negative 3 to infinity. So you'll see I have that right here. My range is bottom to top, so if I smush over to here, it would be negative infinity to 0, union 0 to infinity. Got it, right here. Increasing, this one never does, it's not a reflection. Decreasing, it's decreasing on the entire domain. Oh, I need to fix that, right? Because I copied and pasted. So decreasing, I'm decreasing on the entire domain, so I just need to copy this and put it here. All right. And why? Because I'm decreasing from negative infinity up to that asymptote, and that asymptote is negative 3. And then I start again on the just on the right of negative 3, so negative 3 to infinity. Where's this thing positive? That's above the x-axis. That's right here. That's from negative 3 to infinity on forever. Where is it negative? Remember, left to right. So negative infinity up to, ooh, negative 3. Okay. So negative infinity to negative 3. And then my right in behavior, remember, this is just going to be my horizontal asymptote, which is 0. So as x goes to infinity, y goes to 0. As x goes to negative infinity, y goes to 0 as well. Pause me, rewind me, whatever you need to do, but finish up note card 295. All right, we got 2 more note cards. We're almost there. So note card 296, what about this one? We have 2 transformations going on, right 2, down 3. So the new vertical asymptote is going to be x equals 2 because it was on the parent x equals 0. So we go right 2 to get x equals 2. And the new horizontal asymptote was at y equals 0, but we're going down 3. So now it's at y equals negative 3. I plop those over in the diagnostics. All right, so using Desmos, that's what I typed in. And I also clicked the x-intercept because this one had an x-intercept that would affect the positive and negative intervals. And then, of course, the red line is the horizontal asymptote at y equals negative 3. The black or the dark gray line is the vertical asymptote at x equals 2. And the purple line is the rational function. All right, so my domain. If I smush the purple branches up to the x-axis, everything would be covered but the point, the vertical asymptote value, which is 2. So negative infinity to 2, union 2 to infinity. There we go. Now my range is bottom to top. This is the only one we actually like denote with y values. So if I smush the purple over to the to the y-axis right here, it would be negative infinity up to whatever this y value is, which is negative 3, and then negative 3 to infinity. So there it is. Increasing, never. Decreasing on the whole domain. Okay, so just copy the domain down. So you just need to hope you have the domain correct, or you can just double check. Decreasing from here to here, which is negative infinity to 2, and then from 2 to infinity. All right, positive. This is the origin, guys, right here. So I'm positive just this little sliver. So left to right, from the vertical asymptote, which is 2, to the point 2.333. So there's where I'm positive. And I'm negative from left to right, negative infinity to 2, and then I pick back up at this x-intercept, union 2.333 to infinity. Now my right-hand behavior, these are going to be your horizontal asymptote values, which is -3, so I know I'm right, but think about it. As x goes to infinity, your y values are getting closer and closer to that horizontal asymptote. So there we go. And then as x goes to -infinity, same thing. Pause me, remind me, but finish up note card 296. All right, lastly, we have note card 297 where we have a reflection, okay? So there are no actual movements up and down or left and right. I'm going to put that on here, or left and right. Therefore, the asymptotes are the same as the parent function. So HA is y equals 0, and the VA is x equals 0. So I went ahead and wrote those in the diagnostics over here. Using Desmos, I typed it in. Guys, you wouldn't have to type in all these asymptotes, but I like you to be able to see them. So that's why I type them in. If you don't type them in, all you're going to see, all you're going to see, let me take these asymptotes out. All you're going to see is just the function, and that's okay. I mean, that's okay, but I like you guys to see them. So I'm going to put them back in here. There they are. All right. Now, the red line is the horizontal asymptote at y equals 0, the black line is the vertical asymptote at x equals 0, and the blue line is the rational function. The domain, if I take the blue branches and switch to the x-axis, is -infinity to 0, union 0 to infinity. Range is the same thing. Y'all, this is increasing on the whole domain. Look, left to right. It's increasing all the time. So on the whole domain, it's never decreasing. It's positive here in this branch in the second quadrant, so -infinity to 0. It's negative in this branch in the fourth quadrant. So, ooh, I need to fix that. 0 to infinity. Okay, so that's negative. And then my right-hand behavior, this is just going to be my horizontal asymptote, which is 0, but as x's get bigger, y's go to 0, and as y, I'm sorry, yeah, and as x's get smaller, y goes to 0. So there you go. Good job.